So the concept is same. Whenever you have the bead, whichever vertex we'll be solving, we resolve only that point. So each of the three light inextensible strings has a particle attached to one of its ends. The other ends of the string are tied together at point O. Two of these strings pass over fixed smooth pegs, so there's no friction, and the particles hang freely in equilibrium. The weights of the particles and the angle between the sloping parts of the string and the vertical are shown in the diagram, given as sine beta is 0.8 and cos beta is 0.6. So show that W cos alpha equals 3.8. So if I resolve these two, this 7 Newton string which passes over the pulley, if I resolve these two vertically and horizontally, and this W newtons horizontally and vertically on the other side, I may be able to say that this is exactly 7 newtons, this is W newtons, and we resolve them. This becomes W sine alpha. On the other side, this is 7 sine of beta, and the vertical in red is W cos of alpha, and vertical in blue is 7 cos of beta. Now when we resolve horizontal and vertical. So there are only two forces in horizontal direction, that is 7 sine of beta, which is equal to W sine of alpha. So sine beta is 0.8. 7 into 0.8 is equals to W sine alpha. The second equation would be the vertical ones. So upwards is W cos of alpha plus 7 cos of beta, and downwards is 8 newtons. Getting it? So now we just substitute the values. W cos of alpha plus 7 cos beta is given in the question, that is 0.6 equals 8. So W cos alpha is equals to 8 minus 7 into 0.6 is 4.2. So 8 minus 4.2 is 3.8. W cos of alpha is equals to 3.8. First part done. And find the value of W sine alpha. So W sine alpha, which is in the first equation, equals 7 into 0.8, that is 5.6 W sine alpha. So both sections of the first part done. Second says hence find the value of W and alpha. So once we have these two equations, we can solve them. Equation 1, equation 2. Now I am dividing equation 1 by 2. So equation 1 says W sine of alpha. When I divide this with equation 2, that is W cos of alpha. On the other side, 5.6 divided by 3.8. W cancels with W. Sine alpha over cos alpha is tan alpha. On the other side, 5.6 by 3.8 gives you 28 by 19. So alpha is equals to tan inverse 28 by 19, and the answer is 55.8 degrees. So once we are done with alpha, you can find W, use any of the equations. W sine alpha is equals to 5.6. So W sine alpha is 55.8 equals 5.6. W equals 5.6 by 55.8. Sine 55.8, that is 6.77 newtons. Clear? Question number 26 says two light inextensible strings are attached to a particle of weight 25 newtons. The strings pass over smooth fixed pulley and have particles of weight A newtons and B newtons, both are unknown, hanging vertically at their ends. The sloping parts of the string make an angle of 30 and 40 degrees respectively with the vertical as shown in the diagram. The system is in equilibrium. Find the values of A and B. So same rules, we will split these into two, horizontal and vertical forces. So this is B which acts right here, that is A which acts right here, and vertical and horizontal forces. So horizontal part of this equals horizontal part of that, which would be A sine 30 is equals to B sine of 40. On the other hand, when we resolve the vertical forces, both of these are upwards against the weight. So 25 is equals to, when you resolve A, that is A cos of 30 plus B cos of 40. Now we have two simultaneous equations and we solve for A and B. So if I make A subject in the first equation, that is sine 40 by sine of 30. So 25 is equals to, when you replace A, that is B sine 40 by sine 30 into cos of 30 plus B cos 40. This time I'm going to try to plug this all of it once in the calculator. So I'm doing sine 40 divided by sine 30 times cos 30 plus cos 40 all at one time, and that leaves me with an answer of 1.8793 and so on B. So 25 divided by 1.8793 is equals to B. I'm punching whatever is in my calculator. So 25 divided by, the answer is 13.3. B is equals to 13.3 newtons. And then we substitute this in the previous equation to get A, which is 13.3 times sine 40 by sine of 30 times sine 40 divided by sine of 30, and this shows 17.1 Newton. Okay, that's right. Question number 37 says, given that tan of alpha is 12 by 5 and tan of theta is 4 by 3, show that the coplanar forces shown in the diagram are in equilibrium. If they are, horizontal forces and vertical forces, their sum must be equal to 0. So I am resolving this 50 newtons towards right and this 78 towards left. So that is 58 cos of theta should be equal to 78 cos of alpha. And I am resolving this given information separately. This information shows that tan of alpha, if this is alpha, is perpendicular over base, and when we apply Pythagoras theorem, I get 13. On the other hand, when it is given that this is theta, it says this is perpendicular over base, and when I apply Pythagoras theorem, I get this as 5. Why am I doing so? To avoid decimals and to avoid finding the value of this theta. So cos theta, from this triangle I can see that it is 5 by 3. So 3 by 5. On the other hand, cos of alpha from the given triangle is 5 by 13. So 78 into 5 by 13. 5 1 times, 5 10 times, 10 into 3 is 30. And 78 by 13 is 6. So 3 1 6 6 5 times is 13. So horizontally it is shown, and we do need to show it vertically as well. So 78 sine alpha is this force which goes upwards, plus 50 sine theta again upwards, should equal to 1112. So 78 again sine alpha from this first triangle is 12 by 13 plus 50 sine of theta from the second triangle is 4 by 5 should equal 112. 1 times 6 times, so 12 into 6 is 72 plus 5 1 time, 5 10 times, 10 4 times is 40, and 72 plus 40 is 112 equals 112, shown that it is in equilibrium. Question number 40 says a small ring P is threaded on a fixed smooth horizontal rod AB. Three horizontal forces of magnitude 4.5, 7.5 and F Newton acts on P as seen in the diagram. Given that these three forces are in equilibrium, find the value of F and theta. So again we resolve right equals left or sum of forces equals to 0. So let's try it another way. Right equals left. Only the force F, that is the component on right, it is F cos theta is equals to this component on left is 4.5 cos of 20 plus this component again is towards left is 7.5 cos of 60. Okay, given that these forces are in equilibrium, find the value of F and theta. And we do not need to consider the mass in first equation. So F cos theta is equals to, all of this is known, that are numbers. So 4.5 times cos of 20 plus 7.5 cos of 60 is equals to 7.978, approximately equal to 7.98. That is F cos theta. Now when we resolve it in vertical direction, it is 2 upwards and 1 downwards, which is F sine theta plus 4.5 sine of 20 is equals to 7.5 sine of 60. So F sine theta is equals to, using calculator, that is 7.5 sine of 60, and we subtract 4.5 sine of 20, it is 4.956, approximately equal to 4.96 F sine theta. Now I'm using these two equations to solve for theta. Again, equation 2 divided by equation 1 to get tan. So F sine theta by F cos theta is equals to 4.96 by 7.98. We get rid of this F, that is tan theta is equals to 4.96 by 7.98, 0.621, and theta is tan inverse of this, and angle is 31.86, writing 31.9 to 1 dp. So when you get theta and we solve for the force using any of the equations, so F sine 31.9 is equals to 4.96, force is equals to 4.96 divided by sine 31.9 leaves a force of 9.386. Second part says it is given instead that the force is 9.5 and this angle is 30 degrees. So for the horizontal forces only, to find F net in horizontal direction, this 9.5 component is going towards right, that is 9.5 cos of 30, all other are towards left. So minus 4.5 cos of 20 and minus 7.5 cos of 60. To solve for net force, 9.5 cos 30 minus 4.5 cos of 20 minus 7.5 cos of 60. So I get 0.248. newtons. This is the net force in horizontal direction. Then we use F equals ma. Net force is already there, 0.248. Mass is unknown. Acceleration is 1.5. So mass is equals to 0.248 by 1.5. And we get 0.165 kgs or 165 grams. Clear? Let's have a look at question number 2041. A particle P of mass 0.3 kgs is held in equilibrium above the horizontal plane by a force of magnitude 5 newtons. So particle of 0.3, 5 Newton force vertically upwards. The particle is attached to two strings PA and PB. This is PA, this is PB, of length 0.9 meters and 1.2 meters. The point A and B lie on the plane and the angle APB is 90 degrees. Whenever we have 90, that is easy to resolve. See diagram, find the tension in each of these strings. Okay, so before we resolve this 0.3 kg, W equals mg, mass is 0.3 times 10. This is 3 newtons. So this 3 Newton force would be downwards. So in order to find tension in the two strings, we need to resolve them horizontally. Let me say tension in AP would be T1 and tension in PB is T2. So once I resolve these two vertically and horizontally, so if I say this is theta and this is alpha, we can say that T1 cos of alpha is equals to T2 cos of theta, right? And on the other side, when we resolve them vertically, I can say T1, which should be downwards. Force of tension is taken always away from the point. I'm resolving it at P. So T1 sine of alpha downwards plus T2 sine of theta downwards plus the weight of the ring, which is 3 newtons, all three downwards, is equals to 5 Newton, which is upwards. Now again we can solve them simultaneously, and before we begin, I know that this is 0.9, I know that this is 1.2, and using Pythagoras theorem, 0.9 squared plus 1.2 squared is 9 by 4. Square root of answer is 1.5. So I have all these three values, 1.5, and I took this angle as alpha, I took this angle as theta. Now clearly from the diagram, I can write T1. When you see this cos alpha, that is base over hypotenuse, means 0.9 by 1.5. So 0.9 by 1.5. So I don't have to find alpha. On the other side, this is T2. Cos of theta is base over hypotenuse, again 1.2 by 1.5. Simplifying them, 0.9 by 1.5 is 0.6. Or rewriting this equation, that is 0.6 T1 is equals to 1.2 by 1.5 is 0.8. 0.8 T2. Same way I can substitute these sine theta and sine alpha using the same triangle. So this is T1, sine of alpha is 1.2 by 1.5, which was 0.8. T2 sine theta is 0.9 by 1.5, which is 0.6. T2 plus 3, or we take this 3 on the other side and write equal to 2. I'm making T1 as subject, 0.6, T2 by 0.6, 0.8 by 0.6 is 4 by 3. So T1 is 4 by 3 of T2. We can substitute it in the second equation. So substituting T1, which is 4 by 3 T2 into 0.8 plus 0.6 T2 is equals to 2. Solving for T2, 4 divided by 3 into 0.8 plus 0.6 is 5 by 3 of T2 equals 2. T2 is 3, 2 times 6. 6 by 5 is 1.2. So T2 is 1.2 newtons. That means in PB. On the other side for T1, using the same equation, 4 by 3 T2, substitute in this, which is T1 is equals to 4 by 3 into 1.2. 4 divided by 3 into 1.2 is 1.6 newtons. So this is 1.6 newtons and the other one is 1.2 newtons.